Okay, so first of all, why are we interested on urban vegetation? So of course, urban vegetation is a multi-benefit solution. There has already been several presentations during the conference also how urban green areas are cooling the atmosphere. Today we have been discussing about the impact of green areas on air quality, and what is my interest currently is that how are they uptaking carbon dioxide from the atmosphere. Most of our and why am I interested is that most of our knowledge on urban carbon sinks is based on natural ecosystems, even though the conditions can be quite different for urban green areas, for vegetation in urban areas. There is more variability in species. It's more complex. We have trees, shrubs, meadows, perennials, lawns, and so on. Also, the kind of growing conditions are quite different. We have the urban heat island effect. We have the pollution. We have also can have limited soil water availability. On some areas, on the other hand, we have irrigation. So of course, that is also very different what comes to the natural ecosystems. And also, usually we have more separated trees, which makes that the trees don't need to compete with each other that much when they are separated more than in forest areas. In general, the role of trees as carbon sinks in urban areas has been well recognized, whereas other vegetation types and also the impact of soils have been largely ignored or neglected in studies. And then we come to the final conclusion that, okay, we need more observations to really understand what is going on in urban areas, what comes to the carbon sequestration, and of course it's linked to the water fluxes, because whenever stomata opens and uptakes CO2 from the atmosphere, water vapor is also released to the atmosphere. So the specific study aims are to use different approaches to measure the carbon and water exchanges of urban vegetation at different scales, to get comparisons, to get supplement, so that the methodologies will be supplementing with each other. Also, we are interested in getting information about the role of different types of vegetations in taking up carbon from the atmosphere. So in order to do this, we have had a few different projects at the University of Helsinki and in Finland, where we have conducted very intensive observation campaigns around the Esko observation tower located in Helsinki. So the tower has already been operational since 2004, and it's also one of the associated ecosystem stations, and there we are continuously measuring the CO2 and water fluxes. So what we did during these observation campaigns was that we selected 4 different plots close to the Esko tower, where we have intensively monitored trees in these locations, soil conditions, and also if there's lawn growing under the trees or in general on the plot area, also monitor lawns. And then we have also had different kind of experiments for meadows, lawns, and so on at these sites. You can see the list of observations that we have conducted on the different plots, so which were the street, tree, forest area, park area, and then an orchard area. So there's a list, but maybe what I would just maybe want to emphasize are a few selected examples of data. So here you can see a subflux density measured at the different plots by different tree species. You can see how the forest birch is having the smallest subflux density, and the apple at the orchard the largest subflux density. And what we have been doing, there's now paper in discussion, for example, where we have evaluated that how these subfluxes are affected by drought and heat wave in Helsinki, finding that the drought has more impact to these compounds rather than the heat wave. Okay, first of all, the local heat wave in Helsinki is a little bit different scale, so it means 30 degrees, so it's kind of maybe understandable that it doesn't affect that much, but in any case. Then on the right-hand side, you can see, so we have also these automated chute chambers measuring at the park site. So the symbols here, the black symbols here, are presenting these 3 different chute chambers in the park, and then the lines are just representing that how are models, two different kind of models run by our colleagues from the Finnish Meteorological Institute, that how are they comparing with the observations that we are doing. So large part also this is, of course, we want to understand how urban vegetation behaves, but also we want to have data for model evaluation. And of course, the whole idea of also these 4 plots that we made around the ecovariance towers is that the tower is always measuring the net CO2 exchange. So if we want to understand how the vegetation is actually behaving, we need these supporting measurements. So that also brings us to our next kind of observational technique or topic that we have been doing. So I already mentioned that ecovariance measures the net exchange. I mean, ecovariance is nice because it's the most direct mean of measuring CO2 exchange or water exchange in any ecosystem. But the challenge is indeed that it's a net. So the total net ecosystem exchange is represented by the anthropogenic emissions. Then we have the photosynthesis GPP, and also we have the soil and vegetation respiration. There has already been a decades of work on trying to separate the different components in this net ecosystem exchange measured by the ecovariance. So what we have been now testing last summer, and we are still continuing the observations this year, is that we are planning of using the carbonyl or examining the usage of carbonyl sulfide COS on used to approximate the photosynthesis, and then if we are able to estimate the respiration with the aid of temperature, we are only left with the anthropogenic components. So how the COS is working is that the photosynthesis is depending on this kind of equation, where we have the COS flux measured by the ecovariance, then we have the relationship of the molar fractions of CO2 and COS, and then we have this LRU, which is the leaf relative uptake. So that tells the relationship how a stomata is uptaking CO2 relative to COS. What we have been doing is that so you can measure these 3, and then you need to estimate this one. And on the next slide, you can see how we have tried to estimate it with different type of methods. So, basically, so what we do is that we calculate GPP, we estimate the respiration, and then we are interested on what the end result of here will be. If we first have a look on the left-hand side figure, which is just simply showing the diurnal variability of the COS flux measured in Helsinki, and also comparison to a boreal forest located in southern Finland. And then there's also the net ecosystem exchange measured by the ecovariance system. So the top lines are just showing simply the NEE, with the greater photosynthesis taking place at daytime, and then at nighttime there's a respiration is dominating with positive NEE values. And then the latter 2 ones are the COS fluxes measured in Helsinki and Hyvinkää. We can see that at daytime, the COS flux of the urban vegetation is similar magnitude as the one from Hyvinkää, whereas then a little bit larger differences at nighttime are seen. So then what we have been doing is that we use this one and these and 3 different methods to estimate LRU. I'm not now going into detail on the 3 methods, but anyway, we are calculating GPP, R-echo, and of course NEE calculated ecovariance observations, and then this is now presenting the anthropogenic CO2 emissions at the site. I will now just only focus on the PAR, which means that the LRU is determined by a simple equation with the aid of PAR radiation. And you can see, if we look at the blue line, we can see how the daytime maximum anthropogenic CO2 emissions are reaching roughly 6 to 7 micromoles per square meter per second, which is roughly the magnitudes that we have been estimating using modeling and independent modeling approaches for this anthropogenic heat flux. So this is bringing kind of trust that this is a methodology that we can be used, at least at the Kumpula site, on estimating what are the photosynthesis values and separate those from the other components of the net ecosystem exchange. Of course, one alternative method is that you have this neighborhood level ecovariance tower where you measure also anthropogenic emissions. But of course, one method of measuring more locally, measuring urban vegetation, is that you just simply establish a smaller ecovariance tower. So this is what we did over 2 years. So we put an edifice tower over an urban lawn. It was a bit more than 1 meter high edicovariance tower. And there we are interested on the net ecosystem exchange of urban lawn, but also on the impact of construction and management practices on the capability of the lawn to uptake CO2. Here you can see how part of the area at this site was reconstructed and allowed to grow again. So this is from the beginning of the measurement campaign when the grass was still growing. So how does then the lawn CO2 flux look like? Here you can see a monthly diurnal variability, and you can see how or in between May and November we can see a CO2 sink, so the lawn is uptaking CO2. On other months we see almost nothing, and that's also the time where there was snow present. I know that from North America, from lower latitudes, they have been detecting photosynthesis from urban lawns still in February, for example, but in Helsinki that's limited by the solar radiation and of course the snow. When we compare, if we calculate annual values, we can see how the annual sink of the urban lawn is around 105, and that's actually about half of what has been seen by boreal forests in Helsinki. So when we are always kind of easily, we are neglecting lawns, but we shouldn't do that. I mean, even though it's half, but usually you have quite wide areas of lawns actually in urban areas. And then also the value in Helsinki is a little bit smaller than commonly obtained for urban lawns, but as I mentioned, these are for different latitudes usually. Just briefly, last slide. So this is just showing, because I mentioned that we are interested in the constructions. So this is showing that how this is the total around the whole lawn, and then we have calculated the cumulative sums for the old lawn and for the new lawn areas. And you can see how the old lawn is a much greater sink. Well, it's a great sink of 140, whereas then the new lawn is acting as a source for CO2. And why it's acting as a source for CO2 is that usually when you are building, when you are establishing a new urban vegetation, you are always constructing the soil, and usually the new soil has quite high numbers of organic carbon, which is then releasing back to the atmosphere. This will balance out along the years. By, for example, street trees that we have studied in Helsinki, when you plant the street trees, it will only be a sink after 15 years, and that doesn't even have the emissions created by planting the tree, just when the tree is existing there. So with that, I leave take-home messages, and thank you for your attention.
Thank you, Professor Leena. So we might take one question from the audience.
Thank you, very cool. My question is to use carbonyl sulfide as a proxy for GPP. We're generally assuming that the non-plant sources and sinks of carbonyl sulfide are zero or negligible, or at least known. And we know that there are certain industrial and other anthropogenic processes that produce some carbonyl sulfide, and I'm just wondering if you have included that in here. And it's a kind of, I have selfish motivations in asking that because we are also hoping to use carbonyl sulfide in our Auckland project, and I've been rolling around how to account for that, and I'm just curious what approach you take.
So the edicovariance measurements in Helsinki are in a way cool or convenient. People think that it's complex, but I take advantage that it's a complex site. So one of the directions, as you can see to the east, is very highly vegetated area. So what we actually, I didn't mention it, so the COS fluxes that I presented are only from this vegetated area. So we have analyzed the COS flux against CO fluxes, and we know that there is no correlation existing. If the wind is coming from direction of here, where you have one of the access roads leading to Helsinki, there we can see some emissions taking place. And this, when we calculate the anthropogenic CO2 emissions, that was actually only for that direction. And I forgot to mention this directional. So of course the challenge is that, for example, we have been doing this measurement campaign in Zurich that will be presented, I don't know actually when is it, tomorrow maybe? So there we can see more emissions of COS taking place. So it depends a little bit on the site where you are at, but good questions and thanks for noticing that.
Thank you very much. Thank you again. We'd like to welcome our next speaker,